let us learn about product of sum. So product of sum or POS form is a Boolean expression where multiple combinations of some terms of variables or literals are multiplied together to form a single output. It is also called as OR, to, and, get. Similar to SOP form, where SOP could be represented by universal NAND combination, here POS can be realized by NOR combination or realization, get realization. So the logical representation of POS form will be sum products, say A plus B, or A bar B, or A bar plus B bar, or A plus B bar. And all these sum products are multiplied together to generate a single output. These individual sum products are also called max terms if that sum term contains all the possible variables or literals either in complemented or uncomplemented form. That is A plus B uncomplemented form or A bar plus B bar in complemented form. We can represent a max term with relation to min term as max term is complement of min terms. For example, if we have A bar dot B bar, then we can represent the equivalent of A bar dot B bar by using a whole bar and then applying De Morgan's to get A double bar plus B double bar, which will actually give us A plus B. Hence, the equivalent mean term of a max term M naught will be A bar dot B bar. So here the difference is only that in max terms we use the logic 0 as high, and in mean term we use the logic 1 as high. Now let us understand what is canonical product of sum or CPOS form. It is also called the standard POS form or conjunctive canonical form. Previously, if we see, we learned that SOP form was also called DCF form. Here SPOS form is called as CCF form. So here it is known as standard if all possible max terms are combined. So for a 3 variable Boolean function, we have 2 to the power 3 equals to 8 max terms. So for 2 to the power 4 or 4 variable Boolean function, we will generate 2 to the power 4 equals to 16 max terms. So here we can see an example of CPOS representation where f of ABC has all the 8 possible max terms. And we represent the max term in the form of ascending order. Let us summarize. So if we are given a question where we are needed to convert a POS form into CPOS form, say we are given the question A into A plus B bar into B, then we will start with adding a 0 to all the single out literals. Previously in SOP form, we multiplied the logic 1. Here in POS form, we will add the logic 0. So it also is in accordance with the term which we found earlier, that max term is the complemented form of min term. So we can understand that 0's complement is 1 and Gates's complement is OR gate. Okay. So A plus 0 will form then A plus B bar as already given, and B will form as B plus 0. Now we know by using this formula that A plus 0 will generate A itself. So then 0 can be obtained by using A dot A bar is equals to 0. For better understanding, we know that 0 plus 0 bar will give us 0 plus 0 into 1 equals to 0. So here, instead of putting A plus A bar, we will put the missing literal. Since B is missing here and it is a 2 variable map, so we'll put B dot B bar. If it was a 3 variable, then we would have also inputted C plus C bar. So in accordance to that, we will then try to solve it. This equation can further be reduced to A plus B into A plus B bar. Here we have used this Boolean algebra rule. After that, we will eliminate the redundant terms like A plus B and B plus A, since A dot A is always A. And then we'll obtain the final max terms. If we are given max terms in the question as max terms 0, 1, 2, and 5, and 7, then by using the truth table, we can represent it as, we'll put zeros across all the max terms given in the question, and we'll put 1 across where the max terms are missing, since max term variable produces always 0 as the logic output high. And after that, we will try to map all the zeros, and the first 0 will generate A plus B plus C. Now there would be a slight confusion with the earlier min terms where logic 0 was written for the min term as A complement. But in max terms, as we know that min term is the complement form of max term, so logic 0 will actually represent logic 1. Logic 0's complement will actually reflect logic 1, and logic 1's complement will reflect logic 0. So here we will be getting A's complement of complement as A. Hence, the first terms will be A plus B plus C. For better understanding, we can just consider for max terms as 0 will be uncomplemented and 1 will be complemented form, and then it will be easy. So if we see this term, it will generate A bar plus B plus C bar. Okay. Thank you.